Hi, my name is Caitlin Todd. I am a Student Affairs Administrator at Purdue Polytechnic in Richmond, and I would just like to welcome you to our Engineering Technology virtual event. Today, you're going to get to hear from several people. You're going to get to hear from some of our instructors and faculty members who are experts in engineering technology and who teach our courses here at Purdue in Richmond. And you're also going to get to hear from myself and our other student affairs administrator, Christy Tollett. So Christy and I, what we do is we work with students in the student service area. So we don't teach courses, but if you need help with application or financial aid information or billing, or you have any sort of questions like that, we are the people that you would come to. So that's what I do here at Purdue in Richmond. So the engineering technology event will go over and kind of give a summary of all of our engineering technology degrees. We have 4 bachelor's degrees in engineering technology fields here at our Purdue Richmond campus. We have an engineering technology bachelor's degree. We have an industrial engineering technology degree. We have the robotics engineering technology degree, and we have the mechanical engineering technology degree. And all of these are 4-year Bachelor's of Science programs. And if you have questions about what courses are required, that would be something that you could ask Christy and myself. And if you have questions about maybe something that's different in each of the majors or what kind of sets them apart, hopefully those are questions that you'll get answered today in this event, and something that you'll learn more about through our instructors and through their content expertise. And you'll be able to determine a little bit more what's different about these degrees and how they're set apart.
Hello, everyone. As Caitlin mentioned, my name is Christy Tollett. I'm the other Student Affairs Administrator here at Purdue Polytechnic Richmond. Welcome to our video about engineering technologies, and I hope you learned something new today, and specifically learned something new about Purdue Polytechnic here locally in Richmond, Indiana. As Caitlin mentioned, we have a variety of roles that fall into our student affairs area here at Purdue and Richmond, but I wanted to add just a couple of things to what she mentioned already. We do academic advising and recruiting. Caitlin would be the academic advisor for any students who enroll whose last names fall into the A through L alphabet, and she is the recruiter in Ohio high schools. Myself, I am the academic advisor for students whose last names fall into the M through Z alphabets, and I recruit in Indiana high schools. So depending on what your last name is and where you reside currently as a high school student, would determine if you would work more directly with Caitlin or myself with admissions and financial aid and billing and all of those things that have been mentioned previously. So again, welcome, and I hope you enjoy learning a little bit more about engineering technologies here at Purdue Polytechnic Richmond.
Greetings, I'm Jim Maley on the faculty here at the School of Engineering Technology at Purdue Polytechnic in Richmond. Long ago and far away, I always knew I wanted to be an engineer. So I picked the favorite college or high school class that I had, which was chemistry, decided I'd be a chemical engineer. Went off to school, which was Virginia Tech at the time, and started studying chemical engineering. It wasn't long before I realized that wasn't for me. Picking my favorite school or topic didn't lead to my favorite program of study. After I checked a few different areas of engineering, was in industrial engineering in a course there and found I loved it. A fascinating area. Went through and finished my degree in industrial engineering, got 2 more in industrial engineering. And my first job was in defense, did work in defense and automotive, electronics, also did work with small business, all in the area of industrial engineering. So 25 years spent working in industrial engineering in the business world. Then I started full-time teaching at Purdue here in Richmond, Indiana. And I want to share some of that industrial engineering experience with you here. So when I think industrial engineering or industrial engineering technology, one of the things that comes to mind is that first word, industry. what does that mean for us for industrial engineering? Well, here are some comments about that. Here in the general Richmond area, here are some companies that do industrial engineering. And at first you go, what? Some of those I know. I've seen some of those names, and other ones it's like, what? That's a picture of the hospital. Hospitals do industrial engineering? What's with that? Let's figure out what that may be here and talk some more about what industrial engineering actually is. And industrial engineering is looking at the whole area of people, process, and product. So we've got this interaction of what's going on, the people side of how you actually create ideas, put those ideas into practice, have people work together to create things, and then produce things and distribute things. The people side of engineering, the designing, that aspect of how people interact. And then there's that process that they're interacting with. What are the steps that people go through to create things? What are the steps that people go through to distribute things? How are those distribution processes put in place? How is a manufacturing process actually created? How is a hospital operating room process put into place? How do you ensure all the supplies are necessary right where they're needed, and it's an efficient way of providing those supplies to people in a restaurant, a hospital, a manufacturing facility, all different aspects of business. It's really kind of interesting. And we support the engineers who are developing and designing the product itself by doing the design of the people process side of businesses and organizations. When I say people, talking about how the people interact, this encourage you to actually take a few minutes after you've watched this video and go watch the one here that is showing on the screen. It says to go do a search for the I Love Lucy Chocolate Factory. Fascinating, just how different people interact and how people do things in a process. And Lucy, of Lucille Ball fame from long ago in black and white TV times, did amazing stuff in showing from a humorous standpoint some of the things that take place. But people, how do people act? How do people interact? How do you design a process for the person? And how do you design product for people? What's the human factor that's involved in those so that you can do it efficiently, effectively, and not hurt people in the process? So safety, other aspects come into it as well. So a lot of things in terms of the people and how people interact with a process is that people side. So I've been saying process and process over and over. Here's some comments about process. Here we've got an example where this one is talking about the anatomy of a bottleneck. So a bottleneck, if you think about something coming out of a bottle, it kind of, the neck of the bottle, it stops it so it all can't rush out at once. It can only go as fast as it can get through that bottleneck. When you're looking at processes, there's always the slowest process out there somewhere that's that bottleneck. And how do you make it more efficient so more can get through that so you can have a better process flow? A lot of tools come into that. Developing those tools, using those tools, analyzing processes with those tools is part of what we do as industrial engineers. Statistics is a piece of that. A lot of neat tool and some elements there that help you be able to look at what's going on and make it better. So people and process. When I think about that, they're all connected. The people are connected to other people, and people are connected to what happens in a process, and process elements are connected with each other. It's a whole system of interconnections that are there. How do we look at systems? How do we look at their interactions? How do we look at this impacting another piece? That's a piece of what we do as industrial engineers to make processes work better, and people work better with others and other parts of our process. You can see here some different things I've kind of got on the screen. You may have looked at these. That top left corner shows a normal flow of straight lines. I go from this to this to this. And right below it's actually a systems view. Well, actually, things have feedback, things feed forward. How I look into the interconnections and see those in a deeper way is a piece of what we're doing. On the right there is a classic system type diagram for process improvement. Plan, do, check, act. That's one that's showing in a loop. So instead of, again, being a straight line, it's going through that it's a continual process. It doesn't just stop, it keeps on going. The lower left, isn't it great? Logic Llama says, wait, hold on, stop talking, show me the data. And we've got some data next to it there. Think about how we make decisions. How do we process? What biases do we have as people to want to do things that match what we already know? How do we get the real data to show this is actually what's taking place so we make informed decisions and wise decisions versus, I like this, let's just do it. There are times where that's great. Often in having the most efficient, effective process, that is not great. So fun things like that in terms of how we look at getting to the data. Then over on the right, lower right there, we've got a person working with robotics. So how do you make it efficient that people and robots work together, the collaboration, so collaborative systems? How do we create those, and how do you work that together so that you have artificial intelligence being a positive thing versus a destructive thing? Pieces of all those come together for what we do with industrial engineering. So industrial engineering technology is something that's behind what's made. It's how we make things and how we do it in an efficient way. It's a behind the scenes type form of engineering. It's not the glamorous, I'm an aerospace engineer that just designed this part of a spacecraft that's launching with SpaceX. That's cool, but what are all the things that go in behind that so that it actually comes into being and it really exists and it's done in a way that's efficient to do? That behind the scenes is what we do as industrial engineers. There are endless possibilities of how this can be applied in lots of different kinds of organizations. I encourage you to check this out and find out more. Be glad to answer questions for you. My contact information is here on this next page. Send me an email. Call and set up an appointment to come visit us here at Purdue Polytechnic in Richmond. Talk with our student services folks as well. We'd love to be able to share more with you about what type of things you could do with a degree such as industrial engineering technology.
Hello, my name is Caleb Hale. I teach engineering courses and run the labs at Purdue Polytechnic in Richmond, Indiana. Today I'm going to take you through and do a show and tell of some of the classes I teach and some of the labs that I run. First off, we have strength of materials. This is where we do destructive and non-destructive tests. The names are just like they sound. So on the right there, you can see a tensile test. That's where we pull a material apart until it begins to yield and then eventually fracture and fail. And we measure that the whole time, and then we can output it with our software as stress strain curves. You can see on the left, we have our UTM. That's a universal testing machine. It can push or pull with about 11,000 pounds force. And in the middle is another simple lab that we do. It's a spring rate lab where we can test the pounds required to compress a spring every inch. Next up, fluid power, hydraulics. These are our hydraulic trainers. The three large gray pumps that you see are variable displacement. That means we can vary the fluid output at any time, and it can also vary dynamically depending on the pressure that the pump sees. And then the blue one on the far left is fixed displacement. It just puts out the same amount of fluid no matter what's going on. So with these, we can go back to first principles like pressure equals force over area, and then build from there and show all of the fundamental concepts of fluid power. This is one of our experimental setups. This is a fluid power driven motor that has a hydraulic brake on it, similar to what you would see on a semi truck and trailer. And we can measure the flow of fluid in and out, the pressure in and out, and then we can see the change in the RPM of the motor as we apply air brake pressure to the motor. And then we can also measure its temperature and see that the temperature increases as we apply the brake. This is another setup we have. This is a basic double acting cylinder, meaning it extends and retracts under fluid power. So with this one, we can set up various plumbing arrangements so we can make the cylinder extend and retract at the speed we want and with the force and pressure that we want. And in the labs, we calculate all this ahead of time in theory, and then we run them all hands-on and verify the theory with lab practicals. This is an example from our thermoforming lab. That's heat power. With this one, you can see at the top there, we've got three different metal bars. One's aluminum, one's steel, and one is copper. And there's a hot plate at the bottom. And we turn the hot plate up to about 300 degrees Celsius. And we allow all three materials to reach steady state. And then we can look at the steady state curve and the steady state temperature at varying heights up from the hot plate. And then we can compare thermal properties of the three different materials. Next up, another class that I teach, and we do lots of hands-on labs, PLC programming. So this one is an example of a four-way intersection, something you go through every time you get in your car. So in here, we program all the timers on delays for the red, the green, and the yellow lights. And this is similar to the logic that's running behind the scenes at every four-way intersection that you go through. So the students go through this course, they learn all the gates required to program PLCs, and then we put them together in a ladder form, which you can see on the right. And when you string the logic together, you can create certain paths that allow lights to come on or other input-output devices to be triggered. It could be motors, cylinders, doorways, anything like that. And then after they have the PLC programming knowledge, then they get to play in the robotic cell automated manufacturing system that we have. This is all enclosed, safety circuits. They go through the safety circuits first, learn that, and then you get to program the robots. Essentially here, a person will load blanks in through that little yellow square door, and then the robot will unload the blank, put it onto the conveyor. The conveyor will go down. The second robot loads it into a CNC mill. The doors close, then milling happens, and the second robot takes the part back out when it's done. It travels down the opposite side of the conveyor, and then the first robot stacks the parts into a cylinder bin, and every four parts, there's an air over oil cylinder that brings the parts back out the little yellow square door to the person when they're finished. And then the cycle can just repeat over and over and over with minimal human involvement. So it's about 90% autonomous. Here we have another room. This features some more of our robots, more of our lab setups, and also our thermoforming machine, which is involved in heat power labs. Also have a machine shop. Here you can see all the traditional manual machines, lathes, drill presses, Bridgeport mills, surface grinders, and we also have CNC capability. We have CNC mill on the left, CNC lathe on the right. And the students go through, they learn how to 3D model, they learn how to create CAM tool paths, and then generate G-code, load the G-code into the CNC machines, and make parts. Here's an example of student project. This is one from this semester. This is for a rod bender. The student's project here was to make a rack for all of his fishing poles, and he wanted to make some intricate bends in half-inch steel. So he created this jig in SolidWorks as a 3D model, and then he generated all the blueprints necessary, and then we machined all the parts, put it together, and tested it. Here's another student of mine, another project. In the middle at the bottom, you can see a stainless steel plug, and then above it is a gasket that needs to go onto the plug, and it needs to be changed about every week at the factory he works in. And their method was to do it by hand, which was really rough on their fingers. People would sprain their fingers, try to use pliers, and then end up breaking the O-ring. So he designed a jig that could be used in just a standard vise to roll the gasket onto the plug without any need for fingers. It could just all be done mechanically through rolling action. So he designed that in my MET 245 class, and then we machined the jig out of Delrin plastic, assembled it, tested it, and then he took it to work, and they still use it. And then I teach all the 3D modeling computer-aided design classes here in Richmond. This is an example of SolidWorks design 3D modeling. So here's a 3D model of a motorcycle one of my students made for his project. So he modeled every piece and then took it into an assembly view and then exploded view. All the parts can be seen here. Here's another example of student project. This is an exploded view of an impeller arm. And then within SolidWorks, we can also do virtual strength of materials. So we can apply loading and then we can see loading in real time of the item. So here, everything in blue is essentially zero stress. And then as the gradient goes towards red, more and more stress is being applied. And we can go in each individual block chunk there and see the stress in it, see where the stress is the maximum, see where it's most likely to fail. And in this case, it's 3-point bending. So we can see that it's most likely to fail right in the center. Okay, we also do bridge modeling. So we can do different variations of trusses, different variations of triangles, and see which is the strongest. So we try to balance weight with strength. And we can do that easily in SolidWorks without having to actually build anything. We can hone our design and then build it. And then here's another example of dynamic modeling. This is for a rocket nozzle that one of my students designed. And within it, we could model the ethanol and O2 particles, and we could generate paths for them to see the flow efficiency of the nozzle. And then we could also see the Mach number or the speed or velocity generated by the nozzle. And again here, blue would be the essentially zero speed particles, and then red would be Mach 2.1 coming out the business end.
Hello, my name is Rex Kanu, and I'm an associate professor of practice, and I'm affiliated with the Mechanical Engineering Technology program at Purdue Polytechnic Institute in Richmond. I'd like to congratulate you for wanting to attend college or the desire to attend college and university, and particularly for looking at Purdue Polytechnic Institute for your choice of institution, and also for considering engineering technology program as your possible career path. For this presentation, I will be focusing on mechanical engineering technology program. We do have two other programs, robotics engineering technology program and engineering technology program. But my main presentation will be just focused on mechanical engineering technology program. And we do offer a bachelor's degree program in MET. And for last year, median salary for MET was about $88,000, according to the U.S. Bureau of Labor Statistics. Also, the job outlook for the next 10 years looks quite promising at 4% annual growth. And it's suggested by the U.S. Bureau of Labor Statistics that this is as fast as the average for all occupations in the U.S. So what do mechanical engineering technology graduates, what do they do? What is their job function? So they do things like designing of engines such as electric generators, internal combustion engines, and elevators. They work with sensors and controllers to incorporate them into machinery so that they can automate machines. And so they will need to have some knowledge of electronics, electricity, and how controllers work. In order to do that, they also develop heating and cooling systems for vehicles such as airplanes, trains, cars, and also for schools and computer rooms that needs temperature, tight temperature controls. Engineers also build, plan, and build and maintain robots. So like I have suggested, we have about 3 programs that we offer at PPI Richmond at the bachelor degrees level. And the MET program has ABET accreditation. ABET accreditation means that there is a body that supervises or assesses all engineering and technology programs in the US if they choose to. So they go through the program, they look at their faculty, they look at their resources, their building, the library, their courses, how they grade things, and they say, okay, you guys have met the qualification to attain a better accreditation. And what that means is that graduates or graduates in that from that institution have a very high likelihood of being successful in the industry after graduation. So PPI Richmond has a better accreditation. So when you come to PPI, what do you expect? What makes us different? We have a distinct advantage in that we have been trying to make sure that our students, by the time they graduate, they have about 3 to 6 semesters of paid internship with area company. And what does that really mean? Well, it means that our students can work alongside professional engineers and who can become their mentor, and they can see firsthand what engineers do at work. And because it's a paid position, they may earn money that could be applied towards their tuition. So they kind of have assistance in paying for their education. But also very important is the aspect of confidence building. And because they've been working with engineers, they do the jobs, and sometimes they work alone. They are building confidence in themselves that when they graduate, they just hit the road running in terms of the responsibility that is assigned to them in their place of employment. So how do we prepare you in addition to the internship? How else do we prepare you academically to make sure that you succeed after your 4 years at PPI Richmond? Well, when you come in as a freshman, we introduce you to design courses to show you how to do 3D designs. And so you use software like SolidWorks, Inventor, or 360. All the software will help you to do 3D design, to capture the features of an object so that somebody can be able to look at the drawing and manufacture it or put those things together to make a new product. From the 3D, you can also change it to a language that rapid prototyping machines can understand, STL, a file extension, so that you can actually go and build what you have designed and see if it meets your expectations. If it doesn't, you can always go back to the drawing and tweak it again to make sure that you get it right. To your right, you can see a lion that was rapid prototyped at PPI Richmond. Again, our students have access to the rapid prototyping machines that we have, and they can use it to do to work on designs that may not even be related to coursework, but enhances their knowledge of design. So from there, we do look into materials. So if you look into your cars, you have metals, you have ceramics, you have plastics. Spark plugs are made out of ceramics. And so the car is built with from different materials. And so we try to expose our students to different materials. What make these materials different? What property makes them to be appreciated for certain applications? So we go through that, and also we go through aspects of material testing. Okay, so you want to use material for a shaft purposes of a car. How do you select the right material? So we go through testing like tensile testing, bending, shear test to make sure we select the right material, or we assess the material property that give us the assurance that what we're selecting will do the job for us. Okay, so we do testing, we do material selection. We have a software called Grand Design EduPack, and this is out of University of Cambridge from the UK. And so it has a lot of material. So you have like hundreds and thousands of material. How can you comb through all this material to find out what you need, which material you need for a certain application? So this software help us to do that efficiently. And that process could be very time consuming, but this software can help us do that job in a couple of minutes. So now that you've selected the material, you've tested it, you've selected it, and you want to process it or change it to the final form in which it will be useful in terms of application. So we go through material processing techniques such as drilling, turning, welding, injection molding, and this is for plastics, thermoforming. We also do heat treatment to show you how, or for students to learn how heat can impact the property of metals such as steel. Okay. In addition to the hands-on and all the turning and processing and testing, we also have to teach some courses that gives us the fundamental understanding of these materials, how they behave, and how we can work with them to achieve our end goal, which is a functional material that meets the need that we're looking for. So we do things like heat power, which is thermodynamics. How do material react to temperature? How can we use temperature and pressure to make sure that the material does what it's supposed to do? We look at fluid power, which is hydraulics. If you look at forklifts, they actually use hydraulics to move the forklift up and down and move load because electrical systems cannot do that efficiently as hydraulic fluid can. So we show them how you can size a pump to make sure that the fluid have enough energy to move a load from point A to point B. We look at strength of material. So if you're designing stuff for, say, like the forklifts, what kind of material do you use? What strength do you need in order to move a load from point A to B? And so we teach students strength of material for plastics, for metal, for ceramics. Towards the end of the fourth year or in the fourth year, you do an industrial project, and it's a year-long project or 2 semester. The course doesn't have any exam. What you do is a project is identified by perhaps most of the time by our industrial partner, and they say, okay, we want to solve this problem. They give you the problem, and you go to study the problem, come up with a solution, then design the solution and see if the solution works by building a prototype and try to collect data and see if you can solve that problem. And it's a very enriching experience. It enhances your confidence in all the training that you've had. And it gives you the opportunity to show your industrial mentors and the people you're working for during the internship that you can deliver. So these are all that we do in order to make sure that when you leave PPI, you are ready to succeed in the industry. So I want to thank you very much for your time. I know you have several choices, but you chose to come to this event. I thank you very much, and I will be very happy to answer any question that you may have. Thank you.
So now that you've learned a little bit more about Purdue Polytechnic Richmond and the degree programs we offer, some of you may have an interest in moving forward with application and admissions information. So what I'm going to do next is just share my screen here and show you how to navigate the Purdue website to access our application and learn more information about tuition and fees, visiting, finding our contact information, and those sorts of things. So just to get to our landing page, you can go to polytechnic.purdue.edu/Richmond. On this page, you will see an admissions tab. If you click there, you can then click on Apply Online Now. All of our applications are online only. As a high school student, you would be a first-time college student. Even if you're earning some college credit while you're in high school, we would still consider you a first-time college student. So if we click there, you'll see a drop down, and the first application would be for Purdue West Lafayette, which is our main campus. If you scroll down just a little bit, you will see applying to a Purdue Polytechnic statewide location. This is where you want to be if you are applying to the Richmond location. So we would click on 2021 Fall Apply. And then as a first-time user, you can click on Create an Account. When you click there, it will prompt you to enter your email address and your first and last name and birth date. Once you hit continue, then it will take you into the application portal. And from here, you can log in and out to complete your application. So if you're coming back as a returning user, once you set up your application account, then you can click here on login and log back in. So a student might create their account, but not finish the entire application in one sitting. That's okay. You can always log back in to complete it. There are lots of ways to get to that application page on the Purdue website. So you can see I just kind of clicked around a few times and got back to it again. When you click on Fall Apply, again, that's where you'll get into the application. But I also want to remind you, in addition to the application, you would want to submit your high school transcript to the admissions office and your SAT or ACT scores, or both if you choose. So our admissions office is centralized and it's located on the main campus. So if you are using a transcript service such as Parchment, Docufied, then you will choose Purdue West Lafayette to have your transcripts sent to. And that is correct. Even though you're applying to the Richmond campus, your transcript, same with your test scores, they will actually get filtered through our main campus, through our central office of admissions. And everything will get connected to your file through our main campus. Same with financial aid. When you complete your FAFSA, your free application for federal student aid, you will choose as your school Purdue West Lafayette. We have a centralized office of financial aid and scholarships, and our main campus disperses financial aid out to the Polytechnic statewide locations, including Richmond. So when you go to fasfa.ed.gov and you complete your FAFSA, again, you will choose Purdue West Lafayette as your school, and that is correct to do that. Also on our webpage, you will find our Student Services tab. So Caitlin and I have both introduced ourselves. We've told you a little bit about us, but you can always come back to this landing page and find our contact information. Our tuition and fees information is here. So if I click on Kokomo, New Albany, Richmond, and South Bend, we all share the same tuition rate. So our tuition and fees for full-time students who are Indiana residents come out to be about $7,500 per year. And that's a really affordable rate for earning a Purdue University degree. So we charge per credit hour. So this chart shows you how many or how much it costs per credit hour. Most of our students, if they're full-time, they take 15 credit hours per semester. So for a student taking 15 credit hours per semester, each year, one fall semester, spring semester, they're going to pay about $7,500 per year for tuition and fees, a technology fee, and a lab fee. So that information is on our website as well. And we also have a reciprocity agreement with 14 Ohio counties. So if you are an Ohio resident, then you can get the Indiana rate if you live in one of the 14 counties. And these are the 14 counties in Ohio that are included in our reciprocity agreement. So we have a lot of Preble and Darke County residents. Those are the two closest counties to us, but it actually expands pretty far north and south into Ohio for the counties that can take advantage of our reciprocity agreement. So hopefully that answers how to get to the application, how to apply, where to send your transcripts, where to send your SAT or ACT scores, and what school to put on your FAFSA for financial aid. If you have more questions about any of those items, as always, we keep saying, contact us, let us know. Caitlin and I will be your personal contacts to help you through any of that type of information.
So I hope that you enjoy this event and that you find it useful in your college search and that you learn a little bit more about Purdue and Richmond and what we do here. So at Purdue and Richmond, we actually have two different locations. We are located at the Innovation Center in downtown Richmond on East Main Street. And at this location, we have all of our administrative offices. That's where my office is and Christy and all of our administrative staff members as well as our computer graphics faculty members' offices are here. And then we also have our computer labs. So if you attend here at Purdue and Richmond, you likely will have courses here at the Innovation Center downtown because this is where we host all of our courses that require our computer labs or use our computers. And then we also host our general education courses here at the Innovation Center, like our English courses and our speech courses and math and those sorts of things. And then our second location is in McDaniel Hall on the shared campus of IU East, Ivy Tech, and Purdue. So in McDaniel Hall, it is in the kind of far back corner of the campus there, and that is where we house all of our engineering technology equipment and all of our engineering technology courses and labs are held there. And that's where you can find our engineering technology instructors most of the time. So those are kind of our two separate locations. So that helps you hopefully get a better understanding of who we are. And hopefully in the near future, maybe you can come visit us in person and see these locations and get a better idea of that.
Thank you again for joining us today. I hope you're walking away with a little bit more information about engineering technologies and Purdue Polytechnic Richmond. So if you have additional questions, please feel free to follow up with either Caitlin Todd or myself. And here you will see our contact information, including our email addresses and our phone numbers. You can call or email us for a follow-up appointment or a visit, whether that's virtually or on site. We are open to either of those. And we just hope to hear back from some of you and help you with your future plans.